Hello guys, welcome back to the channel. Today we are solving another LeetCode problem, that is jump game. And I would highly recommend you should read the problem statement on your own because you know the drill. You should read the problem statement as for 10-15 minutes and then you know the channel where to find the solution that is complex. So let's jump right into the solution. So what problem is asking? Let's firstly discuss that we are given an array of jumps and we have to print true or false whether we are able to reach the last index. There are jumps given in the respective index and we have to say whether we are able to reach the last index or not. As simple as that. But when there is a choice of either to take a one jump or a two jump, even a three jump. So when this happens, there are usually two takes we can take: iterative, then another one is recursive. I have a bias toward recursive because just create a call, apply some base case, you will get the answer. But in iterative, you have to address many if else, many case for me. Quite quite tiresome, but in recursion, you can directly have calls and have a base case. That's it. Everything will be taken care. And also the recursive one is quite intuitive also. Intuitive. Most probably you will be able to have some approach in your mind recursive if you have not done the question previously. If you have done the question previously, you will be able to generate the iterative. But you know, I have a bias towards recursive solution, so we will try recursive, we will do iterative. So let's get into the problem. What we are given, I will do a dry run of the test case only, then you will understand how we can write a recursive code for this. In this index we can make two jump or three jump. On this index we can have one jump, two jump and three jump. From this index we can only have one jump. From this index we can only have one jump. And it doesn't matter how many jumps are at last index because we are at the last index. So the basic thing is what we will do in recursion is we will just see if we are able to reach this from this index, from this index where we can reach, from that index to we reach to some index, from that index we will see we can reach to what other index. So it's like depth first search, DFS. We are going to depth, we go to this index, not this index, not this index. So like it is like a DFS. It's a very basic code, very basic code. But in question there is, you can see uh, in question the constraints are 10 to the power 4 and 10 to the power 5. The recursive solution will be of nk. Here n is the number of index, size of nums, nums, and it is this, the size of jumps. this will not run. But in order to make our recursion doable, we can memoize it. How to memoize it? Uh, let how to memoize it? We can memoize it using a 1D array. 1D array. Why 1D array? Because there is only one thing that is changing. That is the index. That is the index, and we will store the index. We will not. Obviously, index are stored, but at particular index, we will store the state. If we are able to reach to this from this index to which index we are able to reach, because we don't have to calculate it again. For example, from uh, from this index we can reach to the last index, then why calculating for 2? If we can reach to 3, then as a result we can reach to 4. So if it's like a is equals to b and b is equals to c, so a is equals to c, it's like that. We will memorize our code. If you have done enough LeetCode question, you know what what is this and what is this. I'm not getting into deep what is like recursion and what is memoization. I will show you the code. Wait a second. Not this one, this one. Here, just basic call memoization by -1. -1 because it shows there is no state. Currently, there is no state stored in that particular index. This is a basic base case. Why base case? If we are able to reach at the last index and -1, there is the size of the array, given array, we will return true. If memo index is not equals to -1, it implies that there is some state stored at that index. Return that state, and here is our recursion call. I will be starting from 1. Why from 1? Because 1, 2, 3, that, and I is less than equals to nums index. Why nums index? At in particular index, the jumps are stored. We can make that max number of that jumps. For example, at this index, 3 3 is stored, so we can do 1, 2, 3 types of jump. 1, 2, and even a longer 3 1 jump. 1, 2, 3. So that's what it is showing. And plus plus basic recursion call. If what we are doing this what we are doing here is, if if in any case it, it returns true, no more going deep into the recursion, just return from the recursion. That's it. What we are doing here, we are storing just normal state, in which state it was true. In this state we are storing this was true or false. So it's just a normal recursion, but we just store the states. When we store the states, what will be our uh, for recursive? Let me write here for recursive. Time complexity was of nk. Space complexity was O of n, and O of n. This is for 1D array, sorry, vector, and this is for stack. How O of n? Because we can have max jumps. No, at index we have, for example, we have 1, 2, 3, 4. At this index we have 4. So we can do 1 jump, 2 jump, 3 jump, even a 4 jump right off the bat. So the stack height will be, at present index it will be, at present index it will, I think it is O going to, let me see, not O of n. given to this, this, this. No, it will be O of n because at max we can get to O of n. Na? This is the final destination at max because first this call will happen when we then we'll go to this and this and this. So call will happen one by one. So at max when stack. But in memoization, time complexity reduced to O into A and space complexity remains same. These number of new states will be formed. New states will be formed and this is recursion, this is memoization. If we do tabulation, we can get the time complexity will be same of, of nk, sorry, nk, but space complexity can be O of n. Let's see how. Tabulation one is not intuitive for this particular question, but in other question we just have to convert this recursive functions call to just iteration. Let me show you the code of recursive. This one is the recursive, just declaring the DP array, storing 0 at all the places because we cannot reach, initially we cannot reach any place, and -1 if we are at standing at n -1 then it is reachable. So from the index n -2 we are filling the array from the back side from n -2 and we are doing the jumps and we are seeing if we are not throwing ourselves out of the array, and we are seeing if it is true also. If we can already reach that index, then just insert in that index that yeah we can reach, break, there is no further jumps. What I'm saying is, for example, 0 at this index true is stored and this is jump array. At this particular index we have 3 jumps. So if we jump 1 and we have true, then why jump 2 and 3? This is just waste of computation. So that's what we are dealing in there over there. If it is true, just put that index also true and break, because it is not asking in how number of steps. It is just asking if we can reach or not. Take how many, whatever number of steps you like, and dp0 because this is the last state where the computation will stop. So at dp0 we will have our answer. I hope you are getting what I'm trying to convey. Maybe not, but still I'm trying. If you have any doubt you can ask in comment section. It is always open. And there is further in dp question. You must be thinking why I didn't told at the very beginning, if you are watching my videos, that I usually tell what algorithm or data structure we are using, but I didn't told because there will no suspense and you will not get the intuition how recursion to memoization then tabulation. If I say DP now, you will just do DP, and that's why the last approach is time complexity O of n and space O of 1. That is greedy solution. That's why I didn't told about DP, because when people apply DP, when hear DP, they do not think about greedy. Sometimes greedy can be applied. It is a good example of when we can apply greedy. Let's see the code. Basically, in code, we are having a variable. If we are able with the one jump, same case, same thing we are doing, but uh, just in one loop. For example, if this is true, we will check if in one jump, if this is true, then do not check further. Reset the jump to 0. Again check for this index. If in jump 1, if this index is true or not. If true, then reset the index to 0 or not index the minimum jump. If for example, this is true, and if we do a one jump, this is not true, no problem, increase the minimum jumps, because to reach here we require two jumps. If 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 we have that number of jumps in that index present, then only we will decrease the jump to 0 and move to other index, and also we will start filling iterating the index from the back, because you cannot decide the future if this index will reach to last, but you can is, if is from future to present, you know the future, it was able to reach to the destination, so you can compute easily that we are able to reach or not. So let's see the code also. This is the code, this is the minimum jump, and I don't know why I declared it two times int I, just n minus 2, because at n minus 1 we already know, if we are standing at n minus 1 we already reached, so for that case it is true, we increase minimum jumps. If we have that number of jumps present, we decrease the minimum jumps to 0, and we keep on iterating. If coming out of the loop minimum jumps is not zero, return false. If it is 0, then we were able to reach the destination, and it is also a ON solution, also submitted it. So I guess that's it for the solution. I hope you have learned something new. And yeah, I am still a beginner, but I am trying. So can you? You can also try, because in crying there is no development. In taking an action there is development. You shouldn't see always the result. Sometimes it's the journey, not the destination. So see you in the next one. Bye bye. Keep grinding. Keep grinding. And also my spelling are not good. Sometimes I write B to D. There is another, so this is another story. I will tell you some other day. So bye bye. Keep grinding.